I am Larry Hatcher. This is Psych 302 Computer Applications in Data Analysis, and I am going to go over lecture notes, chapter 090, ANOVA with one between subjects factor. Now, specifically, this chapter is actually going to be divided across two class meetings, and in this lecture, I'm going to cover pages 1 through 33. And in a later meeting, it'll be pages 34 through 50. But for this video, it's going to be just pages 1 through 33. It'll get you ready for our first exercise related to chapter 090. It'll be exercise 090-01. That's what I'm preparing you for here. Now, as always, note to my Psych 302 students, remember, you don't need to download the data set or perform the analyses described here. You should simply use these lecture notes as a guide when you complete your exercise, which will involve a different data set. Let's scroll down to page 2, toward the top of page 2. ANOVA with one between subject factor basic concepts. Analysis of variance, that is ANOVA with one between subject factor, is used to determine whether there's a significant and substantial difference between the means of two or more samples. Specifically, you do the analysis if you have a single continuous quantitative criterion variable. The analysis will involve a single categorical predictor variable which consists of a limited number of conditions, typically just 2 to 6. These conditions may be called groups, samples, conditions, or levels. We compute the mean score on the criterion variable for each condition and perform a series of analyses to determine whether the differences between these conditions is statistically significant and of substantial magnitude. The procedure described here is appropriate for a between subjects research design, study in which one sample of participants is in one condition and a totally unrelated sample of participants is in the other conditions. Illustrative investigation, financial incentives, and exercise. Imagine that we're applied psychologists researching variables that might increase a person's willingness to engage in healthier, more active lifestyles. We recently obtained a large grant for an investigation that'll determine whether financial incentives can be effective in achieving this. Dependent variable in this study, our sample will consist of 21 full-time college students. Each participant wore a pulse monitor similar to a Fitbit on their wrist to measure heart rate, number of heartbeats per minute. We recorded their heart rate and we downloaded the participants' pulse monitor information each week. At the end of the semester, we used it to compute the average minutes of aerobic exercise that the individual had engaged in during a typical week of the semester. This average minutes of exercise per minute served as the subject score on the dependent variable. The independent variable. Was financial incentives, the amount of money that the participant received for engaging in aerobic exercise. We manipulated it by randomly assigning each subject to one of the following 3 groups at the beginning of the semester. 1/3 of the 21 participants, that is 7 participants in all, were assigned to the low incentive condition. Oops, we had a problem with the footer there. Where was I? 1/3 of the 21 participants, that is 21 participants in all, were assigned to the low incentive condition. An individual in this group was told that at the end of the semester, they'd be rewarded with $1 for each minute of aerobic exercise that they had engaged in on average during a typical week of the semester. For example, if a person had engaged in an average of 60 minutes of aerobic exercise per week, that person would be paid a total bonus of $60 at the end of the semester. Doesn't seem like much, does it? That's why we called it the low incentive condition. Different group of 7 participants were instead assigned to the medium incentive condition. Person in this group was told that they'd be rewarded with $25 for each minute of aerobic exercise that they engaged in during a typical week of the semester. For example, if a specific participant engaged in 60 minutes of aerobic exercise in a typical week, that person would be paid a bonus of $1,500 at the end of the semester. That's the medium incentive condition. And a final group of participants were randomly assigned to the high incentive condition. These individuals were rewarded with $50 for each minute of aerobic exercise they engaged in during an average week of the semester. Participants in this group, engaged in an average of 60 minutes of exercise per week, received $3,000 for the semester. Our research hypothesis. We predicted the following. Individuals in the high incentive condition will engage in more exercise minutes than those in the medium incentive condition, and those in the medium incentive condition will engage in more exercise minutes than those in the low incentive condition. That is what we hope to find by the end of the investigation. We scroll down. Let's go to page 5. I am at the top of page 5. There, as you know, there's different ways of getting your data into your Jamovi data set. This is the approach that my Psych 302 class will use with their upcoming exercise. Instructions for creating the current data set from scratch. This section shows how to create the current data set from scratch in the Jamovi spreadsheet. If it were not already available to you as an online source. Students in my class have already done some analyses by analyzing data sets that I made available for them to download. With this exercise, you're going to create your own data set from scratch. The initial table of raw data. The following table represents the raw data prior to being typed into a Jamovi spreadsheet. I'm on page 6 now. Here's our data set. Initial table of raw data for participants in the incentives and exercise study. We have 3 columns. One of them is headed participant, one of them is headed incentives, one of them is headed minutes. What is this all about? The first vertical column is headed participant, and it merely assigns a unique participant number to each of the 21 subjects in the investigation. Under the heading participant, we see that this row gives us data for participant 1, this row gives us data for participant 2, and so forth. The second vertical column is headed incentives, and it contains a number which indicates the treatment condition to which a participant belongs. Here's what the numbers represent. The number 1 identifies the 7 participants that are in the low incentive condition. Wait a minute, what do you mean by that? Under the heading incentives, this person has a 1. Oh, that means they're in the low incentive condition. This person's in the low incentive condition. That's the low incentive condition. Okay. The number 2 identifies the 7 participants that are in the medium incentive condition. And that would be these 7 people that are identified with a 2. And the number 3 identifies the 7 participants in the high incentive condition. And that is these 7 people identified with a 3. We go to page 7. The third vertical column is headed minutes, and it contains scores on the dependent variable. Minutes of exercise that a given participant obtained in a typical week. What is this all about? Third column is headed minutes. Oh, yes. Participant 1 was in the low incentive condition and engaged in 46 minutes of exercise. Participant 2 was also in the low condition, and this participant engaged in 40 minutes of exercise. I believe I saved that below. Each horizontal row provides information about an individual participant. For example, first row represents participant 1 who was in incentive group 1, that is low incentive condition, displayed a score of 46 on the dependent variable, 46 minutes of exercise in a typical week. Remaining rows can be interpreted in the same way. All right, we have a data set. We don't have it in Jamovi yet, so let's get started with that. Starting the Jamovi application. As you know, the way you start Jamovi depends on whether you're using the installed version or the online version. If you're using a Windows computer and Jamovi's already installed on it, you'll start Jamovi the same way you start any application. Click the Start icon, lower left corner, reveal the application, scroll to the J applications, and eventually click the link for Jamovi. If you're instead using the cloud-based version of Jamovi, click the following link. It'll ask you some questions, make your decisions, and the interface should open. Make your selection and Jamovi interface will appear. It'll look something like this. This is our standard Jamovi interface. Notice the spreadsheet is empty. We don't have any data in it yet. I am still on page 7, toward the bottom of page 7. The initial and empty Jamovi spreadsheet. Once you've started Jamovi, interface should look like screen capture below. You can see that most of the interface consists of an empty Jamovi spreadsheet, which at this point contains just 3 variables: a variable named A, which appears as the first vertical column, a variable named B, which appears as the second vertical column, a variable named C, which appears as the third vertical column. We see this at the top of page 8. Here is variable A. This column is empty at this moment. Variable B, that column is empty. Variable C, that column is empty too. Typing or pasting your raw data into the Jamovi spreadsheet. To create your data set, you'll type the values that appear in your initial table of raw data, which I presented earlier, into the Jamovi spreadsheet. You can do this either by using your keyboard to type the values one value at a time, or if you had already previously typed your data into a Word document or an Excel spreadsheet or something similar, you can just copy the variables directly from that other document and paste them into the columns of the Jamovi spreadsheet. So go ahead and key or paste your data into the Jamovi spreadsheet at this time. After keying the values presented earlier into the spreadsheet, it should look something like this. I'm on page 9 now. Let's imagine I took 10 minutes and actually typed these values in here. Participant 1 was in group 1, and I typed 46 for the number of minutes. Participant 2 was also in group 1. I typed 40 minutes there. These are the values I have typed into the spreadsheet. Now notice, nothing's labeled yet. This thing is called variable A. This is variable B. This is variable C. Surely we can do better than that. And yes, assigning names, assigning variable names and value labels in the Jamovi spreadsheet. First of all, classifying participant as an ID variable. We'll begin by assigning a meaningful name to the A variable. To begin this process, double-click the heading A, which appears at the top of the first column as shown below. See this little space here to the right of the letter A? Double-click that space, and it will open up the data variable panel for variable A, this first variable. Double-click it, and it opens the data variable panel for this first variable. See why we call it the data variable panel. Here, I will provide information about variable A. In the box that appears directly below the heading data variable, replace the name A with the name participant. That is, click this A if necessary and replace the A with the word participant. Click the small downward arrow in the box that appears to the right of the heading measure type, and from the resulting drop-down menu, select ID. This will cause Jamovi to treat this first column as an ID variable that simply assigns a unique identification number to that participant. What is he talking about? Here, measure type, click that and change it from nominal to ID. When finished, your data variable panel for this first variable should look like this. I've changed the variable name from A to participant, and I've changed the measure type from nominal to instead be ID. We can leave the rest of it as it is. And we can move to our next variable, which is variable B in this second column. Classifying incentives as a nominal scale variable. Next, we'll assign a meaningful variable name and meaningful value labels to the variable that's currently headed B. Double-clicking the heading B at the top of the second column, the initial data variable panel should look like this. What was I talking about? Double-click this area at the top of the B variable, and it will open the data variable panel for B. We're going to make some changes to this. Do the following. In the box that appears directly below the heading data variable, replace the name B with the name incentives and press Enter on your keyboard to make it stick. If it's not already been selected, click the small downward arrow in the box to the right of the heading Measure Type, and from the resulting drop-down menu, select Nominal. What I'm talking about here is, looks like when I first opened up this box, Measure Type was already nominal. If that's the case, you can just leave it as it is. But if for any reason Measure Type was anything else, like ID, you want to click this little arrow and change Measure Type to Nominal. The directions continue. In the large box headed Levels, click the number 1 and type the word low so that it replaces the number 1. What is this? This is the box named Levels. Right now, Jamovi knows that I have 3 levels, which are currently called Level 1, Level 2, Level 3. I want to be more specific than that. So I click the 1 and replace the number 1 with the name low, so that everybody will know that's the low incentive condition. In the same box, click the number 2 and type the word medium so it replaces the number 2. And in the same box, click the number 3 and type the word high so that it replaces the number 3. Leave everything else as it is. When you're finished, the data variable panel for the second variable should look like this. My variable is now called incentives. It's measured on a nominal scale of measurement, and I have 3 conditions. What I originally called condition 1 is now called low, condition 2 is now called medium, and condition 3 is now called high. We're finished with variable B. Let's go to our third variable, variable C, classifying minutes as a continuous variable. So next we'll assign a meaningful variable name to the variable currently called C. I'm at the bottom of page 12. Double-click the heading C at the top of the third column. The initial data variable panel should resemble the following. So what I'm referring to is double-click this area at the top of the C column to open up the data variable panel for C. At the beginning, it'll look like this. I'm going to make changes to this C variable. And remember, C is the column that contains scores on the dependent variable minutes of exercise. So do the following. In the box that appears directly below the heading data variable, replace the name C with the name minutes, and then hit the Enter key. Click the small downward pointing arrow in the box to the right of the heading Measure Type, and from the resulting drop-down menu, select Continuous. I'm talking about Measure Type, this box. When finished, data variable panel for the second variable should look like this. I have told Jamovi that the variable that's in column C, I'm now going to call it minutes. Minutes is a continuous quantitative variable. It's an integer variable. Jamovi will have assumed that when you change it to continuous. If not, you can change this to integer. I don't need to do anything with the levels box. You change that only if it's categorical variable in the way that incentives was categorical. So when everything looks correct, click the upward pointing arrow that's on the right side of the data variable panel. When everything looks correct, click this upward pointing arrow. Doing this will cause the data variable panel to slide up and disappear. Final version of your spreadsheet is now ready to analyze. It should look something like this. Page 15, here's the spreadsheet in its final form. The first column gives us a unique participant number for each subject. The column headed incentives tells us whether a given subject is in the low condition, the medium condition, or the high condition. And the column headed minutes provides each participant's score on the dependent variable minutes of exercise. This spreadsheet is finished. You're now ready to perform data analyses on your variables. Looks like I have a red font note here. What page am I on? I'm on page 15 toward the bottom. Hatcher's Psych 302 class will not use the approach in the immediately following section. Instead, you will skip to the section headed Requesting Descriptive Statistics and Performing the ANOVA on page 18. So these are just instructions on how to download an existing data set, which is not what you're going to do for the current exercise. We can go straight to our analyses, descriptive statistics and such on page 18. So let's scroll down to page 18. Okay, I'm on page 18 now. And near the bottom, page 18, we see this heading. Stage directions to Hatcher. Hatcher resumes lecturing here. Okay, at the bottom, page 18, we have a heading. Requesting descriptive statistics and performing the ANOVA. Scroll, scroll, scroll. At the bottom of page 19, we get started. Requesting plots and descriptive statistics. Analysis of variance is based on specific assumptions concerning populations from which the samples were drawn. Assumptions such as normally distributed data and homogeneity of variance. Therefore, one of our first tasks will be to request descriptive statistics and plots that will help us decide whether those assumptions have been satisfied. To begin this process, click the Analyses tab to reveal the Analyses ribbon at the top of the Jamovi interface, as shown in the following figure. From this ribbon, select the Exploration icon, and from the resulting menu, select Descriptives. What is he talking about? We go to page 20. We're going to do analyses now. So, if necessary, click the Analyses tab so that the Analyses ribbon is showing. The Analyses ribbon is the one that has icons like Exploration, t-test, and such. From the Analyses ribbon, select the Exploration icon. That should reveal a menu. From that resulting menu, select Descriptives. Doing this produces the initial analysis options panel for the descriptives procedure as shown below. Below the heading descriptives is the variable list box, a box that displays the names of all the variables in the data set. Where am I? I'm on page 20, about halfway down page 20. Here is our analysis options panel for the descriptives procedure. The names of all the variables initially appear here. This will allow us to compute some descriptive statistics. From the variable list box located directly below the heading descriptives, select minutes and click the right pointing arrow to move it into the box labeled variables. This will request that descriptive statistics be computed for minutes. So we will take minutes and move it into the big box headed variables. From the variable list, select incentives and click the right pointing arrow to move it into the box labeled split by. This will request statistics be reported separately for low, medium, and high incentive groups. So take incentives and move it to this box split by. If necessary, click the small arrow icon next to the heading statistics to reveal the names of the various procedures that can be requested. I'm talking about this bar that's headed statistics. I don't see any options there. Well, click the little arrow to the left of the word statistics and it will reveal the options. Then check the necessary boxes so that your panel resembles the figure below. This will produce basic descriptive statistics such as sample size and standard deviations that'll help us understand general characteristics of this minutes variable. If necessary, also click the small arrow icon next to the heading plots to reveal different types of graphs that can be requested, and check the boxes identified in the figure below. This will produce histograms, QQ plots, and graphs that will help us determine whether our data satisfy the assumptions underlying ANOVA. So I'm on page 21, and this screen capture kind of summarizes the things to be done. You should have moved minutes to the variables box. You should have moved incentives to the split by box. You should have opened up the statistics panel and check only these boxes. Check and uncheck boxes so that you're only requesting the things I'm requesting here. And in the plots section, check and uncheck boxes so that you're only requesting the plots and the options I'm requesting here. As soon as you do this, it will produce results in the Jamovi results panel, and that means it's time to add your name to the Jamovi results panel. Some exercises in this course will direct you to add your name to the Jamovi results panel. Here's the steps for doing this, and I'll allow you to follow those instructions when you're actually doing your exercise. Let's keep moving. I am on page 22. Halfway down page 22, we have the heading, Checking Assumptions and Screening Data. Skip to page 23. Here's our table of descriptive statistics. Figure below presents part of the output, a table of statistics created by the descriptive procedure. You've seen tables like this before. The first column gives us the names of the statistics that we're looking at. In this row, we'll see N, or the number of people in each condition. In this row, how many people are missing from each condition. In this row, what's the mean score on the dependent variable for each condition. The second column identifies the groups being compared. The number of people in the low condition was 7, number of people in the medium condition was 7, number of people in the high condition was 7. The name of the criterion variable being analyzed appears here, and it is minutes of exercise. And in looking at these sample sizes, it looks like there's an equal number of participants in each condition. That's a good sign, no obvious sign we did anything wrong. Scroll down a bit, and we have these rows that are labeled minimum observed values and maximum observed values. None of the minimum or maximum values are out of bounds. My scores on minutes of exercise, it looks reasonable that the lowest scores would have been 10 or 25 or so. It looks reasonable if the highest scores were 46, 54, 65. If we'd seen a number like 5,000 here, we would have known something was wrong. There's no obvious evidence that anything's wrong. Continue to page 24. If we were still looking at the same descriptives table, we would see more. The bottom half of the descriptives table provides statistics that will help us decide whether our data satisfy the assumptions underlying analysis variance. That portion of this table is presented in the following figure. Once again, where am I? I'm on page 24. The row that presents variances for the conditions. Variances are relatively similar across the three samples. We'll take a closer look at that a little bit later. Skewness was not bad in any of the samples. Here we see the skewness statistic for the three conditions. This is the standard error of the skewness statistic for those that want to determine whether you've got statistically significant skewness statistics. In our class, we mostly just focus on the size of the skewness statistic. By the same token, none of the samples displayed much of a problem with kurtosis. Here we have kurtosis statistics. I will refer to this a bit later in the text. Let's scroll down to page 25. Page 25, I talk about these statistics. First up, the variance estimates. Homogeneity of variance assumption states that the sample data and the various treatment conditions must come from populations with equal variances. Some experts recommend that we can assume that this assumption is met if the largest variance is no more than 4 times greater than the smallest variance. Table of descriptive statistics above showed that the largest sample variance was 225.57. That was one of the variance statistics we looked at a minute ago. The smallest variance estimate was 156.48. That was one of the variance estimates we looked at a minute ago. Dividing the former by the latter shows that the variance for the medium incentive condition was just 1.44 times greater than the variance for the low incentive condition. Since the largest variance was not 4 times larger than the smallest, we can assume that the homogeneity variance assumption was satisfied. And those are the variance estimates I looked at here. Take the biggest one here and divide it by the smallest one here. As long as the biggest one is not 4 times bigger than the smallest one, you're okay. Going back to page 25, what about the skewness statistic? Now, one of the things we worry about is, do our data display a marked departure from normality? To determine this, we're going to look at the skewness statistic. It indicates the extent to which a distribution is skewed, with one tail being longer than the other. When a distribution is perfectly symmetrical, one characteristic of a normal distribution, skewness statistic is equal to 0. Larger the absolute value of the statistic, the greater the skew. Huck points out that many researchers view a distribution as being approximately normal if the skewness statistic is between -1 and +1. Preceding figure shows that skewness statistic was within these limits for each of the three treatment conditions, so we don't seem to have a problem with skewness. Here, I'm referring to the skewness statistics in the descriptives table. Notice there's also kurtosis statistics. I bet he's going to talk about that now. He is. Kurtosis statistic indicates extent to which distribution is leptokurtic, that is, a tall peak, versus platykurtic, a flat distribution. When a distribution is perfectly normal, kurtosis statistic is equal to 0. Many researchers view the distribution as being approximately normal if the kurtosis statistic is between -1 and +1. Preceding figure showed kurtosis statistic was within these bounds for these three treatment conditions. So based just on those stats, we don't see any obvious problems yet. What about the plots we requested? I'm at the bottom of page 25, frequency histograms. In the plot section of the descriptives analysis panel, you requested several different types of graphs. Following figure presents the resulting frequency histograms. None of these histograms reveal an outlier, a score that's either extremely high or extremely low and also separated from the main body of scores. That's good news. Okay, here's our frequency histograms. The variable we're looking at is minutes. If you focus on the minute scores produced by the low incentive people, that is almost a normal distribution, and there's no outliers extremely removed from the main group. Medium incentive group is pretty close to normal. The high incentive group is also pretty close to normal. That doesn't look bad. I am still on page 26. Box plots for the three distributions appear here. Box plots don't show any obvious signs of badly skewed distributions. QQ plots at the bottom of page 26. QQ plots can be useful for assessing the normality assumption in a sample. Below we see the QQ plots for the current data. How am I supposed to make sense of a QQ plot? If scores in a sample are normally distributed, data points in a QQ plot should fall directly on the straight diagonal line that extends from the lower left to the upper right corner of the plot. For each of the three samples in our current investigation, data points fall pretty close to the corresponding line. So those dots are pretty much on the line, that's good. Those are pretty close to being on the line, that's good. And those are reasonably close to being on the line, that's good. No obvious evidence of departure from a normal distribution. We scroll on. I'm on page 28. Finally, we're going to request the analysis of variance. That's really what the whole purpose of the previous task was leading to. We want to be able to do analysis of variance. So on page 28, we begin. All systems go. We're now cleared to do the ANOVA. To begin this process, click the Analyses tab if necessary to reveal the Jamovi Analyses ribbon. And from this ribbon, click the ANOVA icon. From the resulting menu, select ANOVA as shown below. Note, from this menu, do not select one-way ANOVA. Although this might seem like the logical thing to do, the Jamovi one-way ANOVA procedure will not produce the more detailed analyses that we need. So to get started with the ANOVA, click the Analyses tab if necessary to reveal the Analyses ribbon. From the Analyses ribbon, click the icon for ANOVA. Do not select one-way ANOVA, instead just select ANOVA. This will open the Analysis Options panel for the ANOVA procedure as shown below. I'm on page 29 now. We know we're looking at the Analysis Options panel for the ANOVA procedure. This heading says so. Here's our variable list. These are the two variables that might be included in the analysis. What are we to do? Identifying the variables to be analyzed. To indicate which construct will be the dependent criterion variable and which will be the independent predictor variable, do the following. Select minutes from the variable list on the left and click the right pointing arrow to move it into the box headed dependent variable. What is he saying? Select minutes and click this right pointing arrow to move it to dependent variable. Select incentives from the variable list and click the right pointing arrow to move it into the box labeled fixed factors. Incentives is going to be our independent variable. We click it and move it into this box headed fixed factors. In the same analysis options panel for ANOVA, below the heading effect size, check the box labeled eta squared. This is the Greek letter eta with a squared symbol. This will produce an omnibus index of effect size called eta squared. Also check the box labeled omega squared. This is the Greek letter omega. It'll produce an omnibus index of effect size called omega squared. So it's going to be check this box, check that box. In a minute, we will see the completed box. I'm on page 30 now. Next, locate the horizontal bar headed Assumptions Check and click the arrow on its left side if necessary to reveal options. There, check the box headed Homogeneity Test. Completing all the tasks described here will produce the Analysis Options panel illustrated below. We have moved minutes to the dependent variable box. We moved incentives to the fixed factors box. We check these indices of effect size. We click the arrow on the assumptions check bar, and in the resulting panel, we checked homogeneity test. Okay, that is step one, but yes, there's more options yet to be requested. We plow forward. I am still on page 30. On page 30. Requesting post-hoc tests and focused comparison indices of effect size. If the F statistic requested in the previous steps is statistically significant, it'll indicate there must be a statistically significant difference between at least two of the three conditions in our investigation. However, the F statistic by itself will not indicate which specific conditions are significantly different from one another. To determine this, we must perform some kind of multiple comparison procedure. For this investigation, we will request a post-hoc test called the Tukey HSD procedure. We'll also request Cohen's d statistic as a focused comparison index of effect size. You'll remember Cohen's d from our Unit 1 t-test. To begin this process, locate the horizontal bar headed post-hoc test and click the arrow to the left of this heading if necessary to reveal the panel below. I'm on page 31. Here's the bar headed post-hoc test. If necessary, click the arrow to the left of it to reveal the options for post-hoc test. We scroll down some. I'm on page 32 now. In the options panel for post-hoc test, move your categorical predictor variable here. My categorical predictor variable is incentives, so I move it from the box on the left to the box on the right. And then check boxes to request these options. So I've checked the box for the Tukey HSD test. I requested Cohen's d as an index of effect size, and I also requested the confidence interval for Cohen's d statistic. And yes, there is more. Finally, we need to request a table that reports the mean score on the dependent variable for each of our three treatment conditions. To do this, locate the horizontal bar headed estimated marginal means and click the arrow to the left of that heading if necessary to reveal its options. The initial panel should look like this. Find the bar that's headed estimated marginal means. If you don't see the options below it, click the arrow to the left and it'll reveal these options. Estimated marginal means, what am I to do there? Scroll down, I'm on page 33 now. About halfway down 33, this is what I am to do. The word incentives is my name for my independent variable, categorical independent variable. I select it and I move it to this box below the heading term 1. So move the categorical predictor variable here to this box. This is telling Jamovi, I want you to compute mean scores for the three conditions of my independent variable incentives. Also, select the following options. Give me marginal means plots, marginal means tables, assume equal weights, that's the default. Give me a plot that reports these mean scores and show me the observed scores in those plots. So check those boxes to request those options. Now I am finished. I am on page 33, toward the bottom of page 33, and finally, Hatcher stops lecturing for the class meeting covering input, assumptions, and analysis. At this point, you know the basics. You know how to create the data set from scratch. You know how to use the descriptives procedure to request statistics that you need to determine whether your assumptions have been satisfied. And you know how to request the analysis of variance itself. At this point, you don't know how to interpret these results. Among other things, at this point, you don't know whether the analysis variance is statistically significant, but we will worry about that in the next unit. At this point, you're now ready to do the exercise in which you'll create a data set, you'll request descriptive statistics, and you'll request the ANOVA. We'll worry about interpreting things later. So at this point, students begin work on Jamovi Exercise 09001, ANOVA with one between factor, input, assumptions, and analysis. At this point, you can begin work on Jamovi Exercise 09001. End of Hatcher's lecture on how to perform the analyses for this specific unit. In the next unit, we'll learn how to make sense of these analyses that we've requested.